So good morning to all of you and welcome to this week session on Python, right? Python programming. And I hope that my slides are visible, right?
Yes, sir.
Good.
Sir, regarding the quiz, when are you going to review our papers, sir? Our quiz, review the answers?
So rather, okay, so you, so for all such questions, please drop me a mail or, so most likely this weekend or sometime like during mid-semester, before mid-semester.
Okay, sir.
Good morning, sir.
Good morning. So, yes, let me start recording also. So, yeah, so recording is also started. So this week we are going to discuss about conditional statements, right? So how do you use more complex construct in programming, which is like the control flow construct, right? So till now, what we have done is like we understood or we have gone through the data types. So what kind of data we can, and simple data types, obviously, that we can use in Python, and we can write some simple statements like assignment statement where we can write some expression, algebraic expressions, which is evaluated and maybe like that value is stored on the left side variable. So x equal to some expression, whether these kind of statements we can write and we can evaluate those expressions and we can understand. So that's fantastic. Like we are all set to write these small like statements, like statement which is like assignment statement. Now to give more structure to your program, right, and do decision making on your program, right? How you can write a little more complex program where we make some decisions, right? So on this slide, this title slide, you can see you're sleeping and then all of a sudden you woke up and you figure out that yeah, we have this morning class, right? And if it is too early morning, then you outrightly decided not to attend this class, right? So is it early morning, right? So you say yes, and no, I'm not interested. So you simply continue your sleeping. It's not that early morning. Let's say the answer is no. Then you ask another question like, is it like Atul sir class, right? And then if it is yes, then probably you're going to attend it. Or if it is no, then you said again, like I'm not going to. So see, you see, we are making some kind of decisions here. This is just like very simple idea that we can figure out a number of conditions in front of us, right? This is very much true in our daily life also, like that we get to have some choices, and then we opt for one choice out of given choices, right? And these can be very orthogonal choices. Or maybe these choices may be dependent on one another, that first you ask the most important question, then you get some answer, and then you ask some more questions based on the answer of the first question. So these are all like ideas or the situations where we navigate through those complex situations and reach to some kind of conclusions or make some decisions. So how these decisions can be made in programs, that's what the idea or the concept that we are going to discuss in this week. And the title suggests the conditional expressions and the conditional statements. So we are going to focus our attention on conditional statements that we are going to make decisions. This is equivalently also known as decision statement. So where we make decisions. And while we make decision, we try to check some conditions, right? And these conditions can be very simple conditions. We'll see that what does it mean by having simple conditions, or it can be a complex condition, which is like a composition of multiple conditions. So those compositions we can call as like conditional expressions, right? Whether they are simple expressions or more complex conditional expressions, they are going to involve in these conditional statements. So conditional expressions, which are integral part of conditional statements, that is what we are going to discuss this lecture. Okay, so from this week onward, we will definitely going to have a bit like more involved programs, right, where we can make decisions and therefore solve those problems where we need to make decisions. So the conditional expressions, right? As I said, we have already gone through some kind of expression, maybe algebraic expression, where we might have seen that x, let's say x equal to 0.1 into y, like raised to power 2 or plus, or so you might have seen this kind of expression. And this we can call as algebraic expression, where those mathematical operands and operators are involved, and you compute these expressions, and the resulting values is assigned to this variable x. Right? Now, this conditional expressions also going to be the expressions, right? Just like these expressions is like algebraic expression, but in the conditional expressions, you will have those Boolean variables, right? Which is being a Boolean condition, which is being computed or evaluated, and the output or outcome of a conditional expression is a Boolean variable. That means it is going to be true or false. So why these conditional expressions are required? Because you are going to verify or check some conditions, whether these conditions are there or not there. So whether these conditions are true or these conditions are evaluated to be false. And based on these conditions, you make decisions, right? So before we get down to conditional statements where we make decisions, we need to know that how do you specify conditions, or that is in the form of conditional expressions. So an expression that evaluates to be true, either true or false, this is what is called as conditional expressions, and is also known as Boolean expressions, right? Or decision expressions is sometimes like it is. So before we get down to conditional expressions, I mean, they are going to, as I said, they are going to consist of those operators where we can have some kind of conditions checked, like verified. So there are relational operators, probably you are already familiar, but just to review this, that we have this like a greater than operator, or greater than equal to operator, or less than equal to, or this is double equal to. It's like you are verifying this x equal to y. That means both values are same. So this is not assignment statement, which is single equal to, but this is double equal to, where we establish that whether this condition is true or not. Similarly, we say that x greater than y. So again, this is going to be a Boolean expression, right? So this relational operator typically can be used to frame the conditional expressions, right? This is one conditional expression. Similarly, you can have, like, this is another conditional expression, right? When we have these operands and these operators, which eventually combine together, results into either output as true or false, right? So there are example of simple idea that you can easily understand, that we have like 3 greater than 2. So you are trying to figure out whether 3 is greater than 2 or not. And we know that this is true. 3 greater than 2, 3 greater than 3, which we know that this is not true, because 3 is not really greater than 3. But 3 can be, I mean, we can say that 3 equal to 3. So that means this is what this will result into a true outcome, right? So all this like expression, which is currently is a relational expression where we are comparing quantity, and the result is going to be either true or false, and this we can call as conditional expressions, right? These are. So similarly, you can see here 2 is equal to, if you're trying to compare these two unequal things, and you would like to check the results, obviously this is going to be false, right? And this you can do with text data also, right? So you can compare strings like CAR and then CARPT, and you can see, like, when we use this less than operator. So I mean, typically this less than, greater than equal to, this operator makes sense when these operands are of numerical in nature, integer data type or floating point data type, real numbers. But can they be also used with to compare strings? And if it makes sense, right? See, in programming, one thing that we need to understand that if some operation between two operand makes sense in some sense, like so, maybe language designer may would like to have this in their language. So, for example, car is less than carpet. So here you have like this string car, right? And then you have this carpet, and we say that car is less than. So we are trying to check this. If it is true or if it is false, and the result is true. Why the result is true? Because this is nothing but a kind of dictionary listing where we know that some words come before then other words, and they are alphabetically sorted. So here you can see this car will come first, then carpet, because carpet has some additional characters, right? So car will come. So you can think about like of a dictionary where these words will have their orders, right? Which word will come first, then the other word, and therefore the result of this such kind of comparison where we are trying to compare these two string car less than carpet, and since car comes first, so we say that oh, car is less than a carpet. This is not mathematically less than. Um, right. So you can see here, and another example is like we have this car equal to car. So now you know that this is uppercase and this lowercase, and Python is case sensitive. So these two are different characters, right? Different set of characters, and therefore they are not equal. So you are going to have like outcomes false. And a car again comes before do this word. So again, like this will return true. 5 is not equal. So this operator not equal to, like compare two operand which are not equal to. So sensibly we can say that they are not equal to. And here 5 is not equal to 10. So it is going to return true. And this is a very interesting comparison which involves floating point numbers. And we'll come back to this idea again. This is very, very subtle and very important to understand that when you compare floating point numbers, then things may go wrong, right? So for example, here for 1.0 is equal to 1 is like true, though this is perfectly all right here. It doesn't make like any exception here, and 1.0 is equal to 1. But very soon, I mean, in this lecture towards the end, we will discuss about floating point comparison, and I'm going to tell you some subtle thing which you should be very careful while dealing with floating point number and using them in comparison operations, right? So we'll come back to this. Then we have this logical operators, which again, I hope that you might be familiar. If not, then again, like no issue. So this AND, what it says, this is like a logical operator. So when there is the logical operator, it is going to take operands as logical operands, right? This Boolean of variables, Boolean values. And so we can say like if let's say A and B, when we write this, then expectedly A is a Boolean operand and B is also a Boolean operand. And when so Boolean operand means they can take values true or false. So we can have like A and B. So let's say A is true and B is true. Then this AND will, so when both are true, the result is true, right? And if one of them is false, then the result is going to be false, right? You know that, right? Probably you know that if you've done some Boolean arithmetic. If not, then still again, I can tell you like this is very simple idea. These that when we use these logical operators, we use them with the logical operands, which is like Boolean values, Boolean variables, and we can use these logical operators to combine these Boolean variables into a Boolean expression. So you can see here again, this will become a conditional expression, right? Because the result of this is going to be true or false, right? Similarly, we have this OR, which is like logical or not. There is one term which is probably some of you are maybe familiar or may not be, which is called short circuiting when you use Boolean operators, right? So we'll discuss this, that what does it mean that we like while evaluating these kind of expressions, which involves logical operator, we don't have to evaluate the whole expression, rather than we can, as soon as we figure out that the result is going to be true or going to be false at any point of time, so we stop like evaluating that expression further, and output either true or false depending upon that what is eventually going to be, right? So we'll see that this is nothing but some kind of efficient way of evaluating more complex logical operations, right? Logical expressions. So this will be very useful when we have very like more complex logical expressions. And eventually we know that the output of this logical expression is going to be either true or false. So at any point of time, if you can figure out that while evaluating that expression, that the output is going to be true, irrespective of the remaining part of the logical expression to be evaluated, right? Then you like stop there, terminate the evaluation, and output the result, right? So that is what is going to be, but how it is going to be, that is what we are going to discuss about, that how we decide to stop further evaluation and output the result as true or false, right? There's something called truth tables for Boolean variables and Boolean expressions, right? So for example, we have this E1 as a Boolean variable, E2 is like simple Boolean variable, atomic Boolean variable. So they are variables, right? And they can take values as true or false, right? And let's say if you apply AND operation between these two variables, E1 and E2, or OR operation is another Boolean operator, right? Then what is going to be the result? So we can figure out that, let's say if E1 is false and E2 is false, when both are false, the output is going to be false. When one is false, E1 is false, let's say, and E2 is true, the output is still going to be false, right? If E1 is true and E2 is false, again the output is going to be false, right? So what it suggests that if we have, like, let's say this E1 and E2 and E3, many, let's say E3 and E4 and E5, with, I mean, more complex expression, where the Boolean operands are connected through this AND operator, right? So it can be more very complex, right? Maybe 10 conditions or 10 Boolean variables might be involved, right? But we know that if one of them is false, then the whole expression is going to be false, right? If one is false, let's say E3 is false, then the whole expression, irrespective of what value they take, they can be true or they can be false. We know that the whole expression, because that is connected through AND operator, and therefore result is going to be false. On the other hand, if it is an OR operator, if this instead of like AND, if it is OR, let's say if all operators are OR, then if one of them is true, then the whole expression is going to be true, irrespective of what is the value of these individual Boolean variable E1, E2, E3, and right. So if one of them is true, then the whole expression is going to return true. So that is what is this information we are going to use to decide to terminate the evaluation further, because we are going to know, we know that the output is anyhow going to be either true or false, right? Depending upon what operators that we are using in that expression, right? So so those who know already, like, this will be very elementary idea which I'm discussing now, but those who don't know about like this Boolean expression or Boolean variable, is again like a simple idea, but it says that this, when we use AND operator, it will output true only when this operands, all the operands connected through this AND, they are having true value, then the result will be true. So you can see like if this is true and this is true, even is true, E2 is true, then only it is going to return as true, else it is going to return as false. If any of them is going to be false, then whereas the OR is going to be different than the AND operator. What it says that if all of them are going to be false, then only it is going to return as false, else it is going to return as true, right? So you may have two operands, even E2, you may have n operand, maybe 5, 10, 15, all are connected through AND. Then if one of them is false, then the whole expression is going to false. And if the operator is OR among all these Boolean variable, then if one of them is true, then the expression is going to evaluate to be true, irrespective of if some of them is going to be false. So this is what, and this NOT operator, the third one, right? What it says that simply flip the output. So if E is false, then it will flip the output as true. And if E is true, then it is going to return as false. So it's simply flip. You know that Boolean variable can take only two values. So flipping a Boolean variable is nothing but changing its value, the other value, right? So if it is false, then not E is going to return true. And if it is true, then not E is going to return false. So you can see some example here, more complex expressions, and even we can make it even further complex by combining more and more Boolean expressions into one single big expression. So you can see like these expressions. So this is one expression, and you can see that we have combined it through this AND operator, and this is another Boolean expression. And this Boolean expression has this expression, which is like y plus 3 is less than z. So this is a Boolean expression, and NOT will flip this value. So if the internal or the inner expression return true, so NOT of this expression will return false, because we are putting NOT in front of. And then we are taking AND between this Boolean expression and this Boolean expression. So you can see that Boolean expressions are uniform, like they can consist of further Boolean expressions. So a Boolean expression can be really much more complex, because it may contain further Boolean expressions, right? So you can actually create more complex logic by combining this simple expression into more complex expression and using this Boolean operator, which is like AND or NOT, right? So you can see here, we are finding some value square root of W, and then subtracting some other value and taking the absolute value of this. And if this absolute value is less than epsilon, again, epsilon is going to be having some value. So if this left-hand side value and this right-hand side value, if it is less than this, obviously it is going to return true or false. And you can see like we are combining this true and false. This whole expression going to return true or false depending upon individual values taken by this W, Z, and then the result of this expression, and then this comparison, and it will return true or false. And then this is OR operator. This OR operator is going to combine with this part of the expression, and you can see like we can have a really much more complex expression. This is one single expression, and you can see like it's more complex one. Obviously, more complex one will be more difficult, slightly more involved to understand and to interpret correctly. So while we can design much more complex expressions, even more complex than this, but obviously the complexity doesn't comes with it comes with a price, right? So, and that price is nothing but your understanding. So you can make a much more complex expression, but can you have you written it correctly, or some combination combination of the values of this variable may make this expression evaluate to be incorrectly, right? So if the expression is not correctly returned, then it will be difficult to figure out that where is the error, right? Why this your program is not behaving correctly. So it will be very important to understand that though we can write much more complex program, it is us only who are the user of this program, right? Or your peers, your colleague going to use your program. So if the program is more complex, difficult to understand, then it will be difficult to modify also, difficult to interpret also, right? So if there are bugs, if there are issues, incorrectness in those expressions, then it will be more difficult to correct them. And you see the programming is going to be a kind of a difficult idea for people, right? So what we try to do while we write program, we try to make this logic as simple as possible so that that we can understand, we can check it easily, its correctness on various inputs if this expression provides a correct output. And also it is readable so that not only just us or who has written this logic, but anybody else who read this code should be able to understand that what you're trying to do using while you write this kind of expression. So what you're trying to achieve, trying to check, trying to evaluate, like the situation that is expressed in the form of more complex Boolean expression. So simple idea is we will keep it simple as possible, but at times you need to write more complex expression. Then you should be able to write them correctly without making errors, right? So because if there are errors, they are the most difficult kind of errors to fix, right? So this is what we need to be aware of, that though we can write more complex expression, we can impress people by writing much more complex logic, but it's not, programming is not to impress people. Programming is to solve problem, right? And your solution might evolve, right? It may upgrade. So other people might will be making modification to your code. So if they don't understand your code, the changes that they are going to make probably will ask for further errors getting into the program, like more bugs getting into the program, and it will be the difficult problem to solve, right? So I hope you understand that this we will be making things more complicated if it is absolutely needed to make it complicated. Otherwise, we will try to keep things simple as possible, and that's the best, one of the best practice of coding that we follow while we write our code. So now coming to the conditional statements, right? As I said, the conditional statements are the statements that we are going to write in the program, right? We are going to make decisions, right? We are going to evaluate some condition, and based on that condition, we are going to take decision. If this is true, if this is this case, then I'll do this. If I earn more money, then I will, I'll do these things. I'll go to like some kind of tour, or I'll go abroad for tourism. Or if I have less money, then maybe probably I'll settle to go to some places nearby, right? So you see, we in a daily life, we make this kind of decisions. And while we solve problem also, we encounter those situations which can arise, which can be different at different times. And therefore, our program is supposed to take care of those different situations. When program may run at different times, and therefore, at every time this program will correctly behave because it has already incorporated those what if kind of situation. What if, another third if. So we can actually write this kind of logic into our program using this conditional statement. Right. So in daily routine, it's like if it is very hot, I'll skip exercise, right? If it is pleasant weather, I'll go for a morning walk, right? If it is very cold out there, then I am going to sleep for longer time. All those kind of things. You know that you make decisions based on situations. So how these situations are captured inside the program, and that is what is possible using these conditional statements. Okay. Okay. So what is the most simple kind of conditional statement, right? And which we can say a simple if statement, right? If. So the program statement in Python, right? Like this if-else statement, you'll find those who are familiar with more than one programming language or some other programming language beside Python, they know that they have gone through this if statement. So this if else again a more general construct, right? And any programming language that you're going to use, you're going to work with, you'll find that they include this statement. Obviously, the syntax is going to be different. Syntax means the actual words and the expression, and this is what syntax, and then we have like this much of space before we write this print, and then we have this part. So you can see like the actual words or the syntax of this statement may differ from, and more likely is going to differ from one language to another language, because that is how those languages were designed by different designers, and they decided that that is what the syntax that they are going to use, or they're going to allow when people will write program in using this language, right? So for Python is no exception. Again, like you need to know that how we can write this if else statement or if statement in Python. So what is the syntax or the structure of this if statement or if else statement? I can tell you, right? This will start with this if keyword. Then we have this expression, which is like Boolean expression, right? So depending upon whether it's much more complex expression, you may be writing much more complex Boolean expression, which we have seen in the previous slide. It may consist of a number of Boolean expression within this expression. So you can write much more complex expression. But to start with a simple idea, let's say we are comparing here, if X is less than Y, right? And then we have this column, which suggests that the following code, which we will be putting here, will form the body of this if, where this condition is evaluated to be true. So what if this condition is true, what is to be done? And if this condition is not true, then maybe you would like to do something else. And therefore that else part is here. So you can see here that this if statement has two code blocks. One block will come here. Right now, here only there's like just one programming statement, but you can add more statements here, all aligning with this word, with this vertical line, right? You know, in Python, this alignment is very important, which is called indentation, right? So Python doesn't use which typically used by some other language like C or Pascal, where we put some code within this curly braces, opening braces and closing braces, and we write the program statement. So all those statements are considered as one block of statement. One block of statement, a sequence of statement which are to be executed all at once, right? So this forms one block of code. That means if the control or execution control comes here within this block, then all these statements are going to get executed in this sequence, because this forms one block, right? And where the block is important in situation like where we have this control flow constructs like if statement. So why this block is it needed here? Because we want that if, let's say, this condition is true, so do these things. I mean, do not just one thing, but maybe multiple things to be done when this is true. So all those multiple things, I mean, all those code is going to like placed here, which will be the part of this if statement when the condition is evaluated to be true. And if it is not true, let's say, right, if X is less than Y is not true, means X is actually greater than Y, right? Or equal to Y, because it is just less than Y. So less than Y suggests that X is strictly less than Y. If X is equal to Y, then this expression will be evaluated to be false, right? So this less than Y suggests that X is less than Y, strictly less than Y, right? If X is equal to Y also, then also like this expression will evaluate to be true. So when X is less than Y, strictly less than Y, then this is going to be true. But if X is equal to Y, then this expression is going to return as false, because that condition is not, so this operator is a strict operator, which suggests that X should be strictly less than y for this expression to be evaluated to as true, right? So this is going to return false when x equal to y. So if x equal to y or more than y, then if something need to be done, I mean, there are two conditions, right? If x less than y or x equal to or more than y, right? So we divide this scenario like when we have these two variable x and y, the two cases, right? Where x is less than y is one case, and the remaining situation, right? Remaining scenarios where x can be equal to y or more than y is another case, right? So that is going to cover in the else part. Now this else is optional here. Please note that else is not compulsory part of if statement. You can actually write this statement without having this else. That means you check this condition, if x is less than y, then do these kind of thing, right? With this vertical alignment, all those statements, they are going to get executed. So that is what you wanted, then when this condition is met. And maybe if this condition is not met, if this condition is false, then you don't want to do anything, right? You said, okay, go, I mean, then don't bother, right? No worries, go ahead further. So whatever the following programming statement will be there, they are going to get executed. So you can use a simple if. So this if else statement can be used simple if also, or if else also. So you can see here, this is an example of if else, that if given, if this condition satisfied, found to be true, then do this, or else, or otherwise do some other things. So, and that's why we have this else. So what here, this intention here is that if this condition is true, then you do one thing, and if this condition is false, you do some other things. That means based on this condition or the result of this condition, you do one or the other thing, right? But you do something, right? You don't ignore any condition here, right? But in case where you write a program where we just check a condition, if this condition met, then do this, else don't do anything. So you don't need else part, right? So we can skip out this else part and we can continue with the following statement, just like this statement. So this is also possible in the sense like we can have if statement without else, and we can have if statement with else, depending upon how you want to use this if statement. How do you want to take action, right? If some condition evaluated to be true, or if it is evaluated to be false, right? So if it is just you need to do something only when the condition is true, and you don't have to do anything if the condition is false, then you can use simple if, plain if without else. But if you have to do something, one or the other, so one thing is to be done when the condition is true, the other thing is to be done when the condition is false, then you are going to use this else statement. So you are going to have in this if else statement two blocks of code. One block of code will be the part of when the condition is evaluated to be true. So that followed by this colon, and then the statement that you're going to write, all those code will be nothing but a code block, because they are going to align vertically, align the same vertical alignment, all that code, and therefore they will be all going to get executed in that sequence, which we are already familiar with, that how program, simple program or few statement that you have written so far are getting executed. So what this suggests, that if this condition is evaluated to be true, all those statements following this, this block are going to get executed in that sequence. And if it is not true, if it is false, that means else block, then again you may have a few statements which is getting executed. And once, so this is your if else statement. This is how we write if else statement in the program. And then your like normal code will follow after that, and whatever logic you're writing, whatever code you're writing, which will follow after this if block will complete. So you can see here, so till now what we have seen, we have written this code is like one statement, then another statement, third statement, all those statements were getting executed without exception. The first one will execute first, the second one will execute second, the third and fourth. So you might have written 3-4 lines so far, and all were getting executed in that sequence and compulsorily. But now here we have a choice that we want certain statement to be executed if a condition met, and certain other statements or certain other computation to be performed when this condition is false. So this is why we call this as a decision statement, or your control flow or flow of execution. As the program is executed one by one, instructions at a time, right? You can figure out that, okay, I want to skip some of the statements, some of the code should be skipped. So when this code should be skipped, you have to specify that those conditions, and those conditions can be expressed in the form of this if-else statement. So we'll see more example, and the things will make it very simple. So for example, here this will suggest that how the execution is taking place when we are going to have this if-else statement in our program. So let's say we have got this x and y, two variable, which is initialized with values 6 and 10. So now you know that when we use this kind of assignment statement, where this is like multiple assignment statement where we are initializing more than one variable in one single statement. That's what the multiple assignment statement, and very useful idea in Python, that we can, in one single line, we can initialize multiple variables. So x will take value 6 and y will take value 10, right? So this is how x and y are initialized in this program. And then now we can use this x and y with the value 6 and 10 respectively, right? So what it's the following code suggests, if x is less than y, which is true here because 6 is less than 10, and which is true, then we are going to get this print x, else print y. And what this print is this function which is outside of this if statement, if else statement. This is a normal statement which we are familiar with. So this print is going to print this minimum, right? So what it is doing here, if you can go through this code carefully, so you know that if x less than y, which is the true, so then it is going to print x, that it is going to print 6, and this else part will be skipped because we have seen that this condition satisfied, then it will go inside this true part of if statement, and that else part is going to skip because true was correct. So obviously the else will be executed when this expression evaluates to be false. That's how we differentiate that what to be done at when, right? So if x is less than y, if this is true, then do this, else do something else, right? That's what the else part of the if statement will be used for, right? So if this here in this program, 6 less than 10, which is true, which when it is going to be evaluated and will return true. So when it will return true, the control, execution control will go inside this if statement, which we call as inside if statement for the true part of if statement. So this block of code, which is currently having only one statement, print statement. So it is going to print x, and therefore x else part will be skipped because that one of the part is only going to execute. If this part is skipped, if this condition is false, then this part is going to execute the else part. And if the condition is true, then this part is going to execute, and this part is going to is going to escape. So this is how the if statement is taken care of, it's got executed, just like one single statement in the program, and then we get the following statement in the program, just like sequentially placed. So we have got print statement. This will execute anyhow, irrespective of whether this part got executed or this part got executed, because this print is out of the if statement, if statement of this program, right? So if statement consists of, start from this point onward, and will go up to this point. So like 4 line of code here in this example, this is one single if statement. Obviously, if else statement, because it consists of else part as well. So that is one single statement. And we know that either one part, this part, or this part, one of the two part is going to be executed. Not both will not execute. And also like none of them will be executed. This is also not going to happen. Exactly one part, either the true part or the false part, it is going to execute. And that is what the if else statement, one single statement in this program. And then the next statement is this. So this statement is not part of if statement. How can it be a part of if statement? If I I put this print statement with this alignment, then it will be part of else statement, or I can put it this print statement here, right? In this vertical alignment, then it will be part of the true part of if statement, right? But since the logic is we want to figure out that given two number, which is the minimum number. So this in this code, what we are doing, we are comparing these two number and outputting which number is the smallest number or minimum number. So what we are saying that, okay, print x. So here we know that since 6 is less than 10, 6 is smaller. So that means this will evaluate x less than y, which is true. 6 is less than 10, then it will print 6. And the else part is going to escape, and then it will print is the minimum. So it is going to print 6 is the minimum, which is the right answer for this program. This program is taking two numbers and outputting which one is the minimum number. Right. So if we run this program, you can see that the execution is going to be of this kind, that x and y is assigned this value 6 and 10. Right, x is pointing to this, y is pointing to this, storing this, right? And then we have got this if statement, if x less than y, which is true, so two branches will be taken. Then print x, so we are going to print, so it is going to print 6, and then it is going to skip this part, which is else part, and it is going to print is the minimum. Right, so you are going to get this output 6 is the minimum. Right, you can play around this code. This is what you need to do while you play around with the demo code. We will have this code, and you can write your code, and you can check some more other situations which comes to your mind and see that what happens. Indentation is important in Python. So again, it is a kind of repeat and a caution to you, to all of you, that you should be very careful that what part of the code will be executed when if the true part of his if statement is, let's say, is exercised. That means the condition evaluated to be true. So what code should be executed? So that indentation are all that code which is vertically aligned by giving some space, right? The exact space, right? That is all that code will going to get executed. So this indentations allow us to group statements, which is called as block of statement, one block of statement. So one continuous block of programming statements, which will be either execute all in that sequence or will not execute at all, because this is forming one single block of this statement. And you can see that it can be either in the true part of the if statement or it can be in the false part of the statement. So that alignment, vertical alignment, is very important. You can make mistake if you are not careful. That some statements not getting executed. Why? Because they are not aligning vertically with the true part or the else part, the false part. So you need to be very careful here. Right. So this alignment. So this is one single statement here when the x less than y is evaluated to be true. But here you can see like we have two statements. So this, if you have this print coming here, then if you run this program, it is going to print only 6, but it is going to skip all that because this is all single block, right? Which is the part of else block of if statement, right? So either it is going to execute all at once in that sequence or none. So this print statement will miss if you have like print statement aligning with that final print statement aligning with this print statement. So this the compiler that will consider that these are in the same block, and therefore they are part of the if block. So they will be executed either all at once. If this condition is evaluated to be false, then this all will be executed. Else, or if it is evaluated true, then this will execute. And since this print is aligning with this print, you can see like this is in the else block, and after that the nothing will be printed. Nothing will be printed because this else block will be completely ignored if x less than y evaluates to be true. And there are nothing after that, so program will simply terminate after printing 6. So you can actually check yourself and can figure out that if this is the case. So as I said, if statement can be used without else, so we can say a Boolean expression. You can always put these small braces to make it more explicit that within this bracket, this small bracket, we have this Boolean expression followed by this colon, and then we will give some space which will suggest that the following code is forming a block of statement, and which will be the part of the statement when this conditions of Boolean expression is evaluated to be true. But there is no else here. We have this S2. So you can see like if is aligned with S2. So what it suggests that if will up to this point, the if will complete. This if statement is over. So following statement is the next statement. So you know that program is nothing but a sequence of statement. This one statement is another statement. So we got two statements. One is if statement followed by S2. So S2 is outside of if. It's an independent statement and is going to get executed every time, irrespective of whether this condition is true or false, right? Because this S2 is outside. Right? So if statement can be used without else, if we don't need like some action to be taken if the condition is false, if there is nothing to be done, why we don't use this else? So its condition is true, then we do something. I mean, we can have number of S2. I mean, we can have number of many statements all aligning with this, and that is nothing but what it indicates that all this code will be getting executed if this condition is true. So it can be one statement, 2, 3, 4, 10, 15, 100, all aligning vertically with this first statement, which is the part of if when this condition evaluated to be true, right? And then there is no else, and then there's S2, S3, S4, and you know that your remaining program is following after that, right? So this is just a pictorial depiction of like that this condition, which is like this expression. If this is evaluated to be true, then S1 will be exercised. So if the program is executing this way, there were some misstatement before this if statement, and then we have this if statement, then it is evaluated to be true, then S1 will be executed, then S2 will be executed. And if it is evaluated to be false, then S1 will not execute, because now the other branch, which is like the false, and false will, there is nothing here. So it will eventually come out of this if statement, and the next statement S2 will get used. So you can see like here we got this two different paths. And depending upon this condition is evaluated, which path is going to be taken, that will depend the outcome of this Boolean expression, right? Okay. And for if else statement, you have already seen if this Boolean expression is if it is evaluated to be true, then S1 and followed by all those statements which are aligning with this S1 is going to get exercised. So basically not just one statement, but a block of statement which are, and how a block of statement is identified, all those statements aligning the first statement within that, right? Else, then we have got S2 and maybe more statements also. I mean, you can write as many as, but then these are the two block of statement. One consists of S1 and following in align with that S1, and then the else part, the statement S2, and following all those statements are ending with S2. That is the else part of it. And then S3 is out of the if statement, and therefore it's independent of, I mean, it's not connected with this if statement. This is like another statement. And your program is nothing but multiple statements, one after another. So if is just one statement. So even if it takes like 4 line of code, 1, 2, 3, 4, right? What we are going to say that this is one single statement, program statement, which is if statement, if else statement, right? So even if it is coming in 3, 4 lines, right, it is still one single statement, right? It has 2 internal part. One is like true part when this expression is evaluated to be true, and another is false part when the expression is evaluated to be false, right? What is to be done? And then we have this remaining program, rest of the program following up after this if statement. So how we use if statement anywhere in the program? By following this syntax. Again, the pictorial depiction of if else, that you either take this branch, if it is true, the condition is true, or you'll take this branch, right? So you are coming this point, at this point, like where the if statement, where it's exercise. So it will exercise in these 2 scenarios, either following this path if it is true, or for this path if it is false, followed by this execution of S3 and other code which is following up. Right. So let's take a little more complex and more example, like finding minimum of 3 number. We have seen that finding minimum of 2 number by simply comparing 2 numbers, and whichever is like smaller, we are going to rule out in favor of that smaller number. So we have seen in the previous slide, the finding minimum of 2 number. Now, what if there are 3 number, right? So let's say we take this 3 number A, B, C. Now, how we are going to check? First, we are going to check 2 numbers. We cannot check 3 numbers at once, right? There is no operation or operator which can allow you to check 3 numbers and figure out that which one is minimum. So we have to write that logic. We can compare 2 numbers, right? If x is greater than y, right, or less than y, or greater than or equal to y, those kind of things, right? So we can compare 2 numbers at a time. This is what is available. Now we want to figure out that how to find minimum among the 3 numbers. So how we are going to solve this problem? By breaking down this comparison of 3 numbers into like these comparisons of 2 numbers, right? So we are going to compare 2 numbers at a time. And after a few comparisons, we should be able to tell that which one is minimum, right? And therefore, see very carefully this logic that how we are comparing these 3 numbers among them, and then finding out the minimum of the 3 numbers. So what we are going to do, first we are going to check the 2 numbers, right? So let's say first and second number, that is like A and B. So what we are going to check is like if A is less than B. Now we know that it can give me 2 outcomes. Either this can be true or this can be false. If A is less than B or equal to B, so I'm using this less than equal to operator, which will return true when A is less than B as well as A is equal to B. That's what the less than equal to operator is. So this checking is semantically interpreted as that if A is less than to B, strictly less than, or A equal to B, in both these cases, this will return as true. And if A is strictly more than B, then it is going to return me false, right? So depending upon the value of A and B, we are going to get these 2 outcomes, true or false, right? So that is how I'm designing my logic. Now I'm starting designing my logic of the program. That's how I can write this program, which will find the minimum of the 3 numbers, right? So I know that when I compare these 2 numbers, I'm going to get these 2 outcomes, either true or false. So in case if it is true, that means A is either less than or equal to. Even if it is equal to, that means it has chances of being minimum if we compare it with C. So that is what I'm going to do. So after one first comparison, if it is true, then I'm sure that between A and B, A is smaller or equal to, right? So A is potentially still the candidate of being minimum. And if we compare it with C, then we can absolutely be sure that whether A is minimum of the three number or C is minimum, because B is already been compared, and what we figured out that B is either bigger than A or equal to A. So B is not less than A, right? So B is not less than A, and if there is some other number C, which is like third number, is less than A, then C is going to be small. So what we are going to do is that we are going to put another check if A is also going to be less than C or less than or equal to C. And again, so that means at one point of time I have checked A with B, and now if I follow this branch, this outcome, then I'm sure that A is actually less than or at the most equal to B. So A is a candidate to become, if we compare A with, so remaining things that need to be ensured that A is also less than C, or at the most A is equal to C, then we can say, okay, A is the minimum, right? And that's what we are going to do. So if this is evaluated to be true, that means A is less than or equal to B, and we also check A is less than or equal to C, that means now we sure that A is actually minimum, and therefore we can print A. But on the other hand, if C is less than A, then since C is less than A, then C is minimum. C cannot be. So you may have some question here that what about the relation between C and B? See, that is need not to be checked, because we have already ensured by following this path that A is actually less than B or at the most equal to B. So if C is further less than A, that means C is also less than B, and therefore we are going to get this that output as C, right? So this is one part which is completed here, right? Either we print A or we print C, depending upon what is the connection between A and C. But what happens if B is less than, right, A? Right? So obviously we are then we will take this path. C is not been encountered when we go through this path. C has not been touched, I mean, not been evaluated how big or small C is. Now, what we are going to do, but what we have figured out at this point of time when we follow this path, at this point of time, we know that B is less than A. So any number which is B is already less than A. So then next we have to compare B with C, and therefore we can say that if B is still further less than C, then B is the least number among the three number, the smallest number or the minimum number. Else we are going to say that C is number, because the comparison between A and B has already taken place, and we have already ruled out whether which one is least among the two number, right? Which is the lesser number between the two number. That's what we are working on. So you can see this simple logic we can write in the code, right? You can see like we have this A, if A is less than B, we have this column, and then the true part of if statement. If A is less than C, so you can see like within this if statement, I'm writing some logic here, right? Which will nothing but ensure that if the result of this expression evaluated to be true, then we will the execution control will come here, right? Aligned with this, right? Else, if this is false, then we will have the else part, which is nothing but this part, right? You can see like the true part is when this side, and false part is this side, right? So if A is less than or equal to B, we need to, so that is, this is true. And that's the problem, right? You get your momentum broken when somebody creates this kind of problem. And I many times requested that please ensure that your mic is mute. All right. So So what the logic that we are going to bring out or bring in this Subodh?
Yes, sir.
Yeah, there is some problems and you need to take care of as soon as this happens. I mean, a little vigilance is needed from your part.
Yes, sir. Sure.
Otherwise, it is disturbing too much. Okay, so what is the time? Let me check the time.
Otherwise, I sent the message. Still,
So
there
person
are some.
All right. Just note down their name.
Sure, sir.
Only I'm just before removing, note down their names.
Okay, sir. Sure, sure, sure.
So again, let's start this logic to get into this program. So what we are going to do, we are going to check first whether A is less than or equal to B or not. The same control flow or the logic that we have embedded in a visual form, right? In the previous slide, you can see, you have seen that. Now we have to write the code. So again, like if statement that we are going to make use of. And if A is less than or equal to B, then we are going to do further comparison, right? So within this true part, we are going to have another if statement. I mean, you see, we are now making use of nested if within if, and this is very much possible. I mean, that's the logic suggests that if this condition satisfies, then you check for another condition, because the first condition is satisfied, then you check the next condition, and then you ruled out the decision. So if A is also less than C, then you print this, and you can see like this indentation here, this indentation here. So this if statement contains another if statement, and the true part of both this if statement you need to be careful, right? Where you are going to put that code. So those alignment is important. So this alignment is for the true part of the outermost if statement, and this inner if statement is going to have like all this true part is here. And this else, now you can see, I mean, things start like messy because you have multiple if and else statement. So which else corresponding to which if, right? And if you are careful, if you're clear, then things are straightforward. But if you're not very careful, then you can really make it mess, right? So things are, again, as I said, simple. Just you need to be very simply thinking about like where to put these if and else part of those ifs, and what else corresponding to what if, right? Because this if has this optional part else. But if you are using two if statements and you are having nesting of one if within another, so again, you need to be careful, right? So here, when I'm using if statement, you know that the alignment of this if statement is this. So the else part of this if statement will align with this. The true part will go here, I mean, with some indentation, some space, at least one space, right? We can add more space. So I mean, to make your code look very clear and so that one can read very quickly. So you should give some spaces, maybe 3-4 spaces, so that, and then all those code statements should be aligned with this. So you got the inner if, which is here, right? Right? And you're making a decision here, either you're printing A, which is you are printing minimum A. So after two comparison in that sequence, if A is less than B, less than or equal to B, and if it is true, then if A is also less than or equal to C, then I'm going to print it. So if it is true, and if it is also true, that means we know that we have reached to this branch. So you can see this we can call it a decision tree, and these kind of visual like design, visual presentation can be very handy because it can allow you to to explicitly represent your logic, and you can play around, you can check your logic before you write your code. So writing these decision trees will allow your code to become straightforward, because that decision tree can be very straightforwardly converted into this if else statements, right? Even if like there are further if statements getting nested within other if statement, then also like it will be simple to write. But if you start writing some complex sandwiching of if statements, right? If within if and more complex and multiple times, you'll find that things can get really difficult to figure out that if your results are not coming as expected. So there may be some error you might have done while you have written this if statements, right? So here it's again like things are simple, but one if within if, like you can see, like we have started here, taken this if statement, it's a true branch, but then there is another if statement, there is another condition which is evaluated. So this is in the form of if statement. So I have another if statement within this if outer if statement, and then after two if statement, I am going to output in favor of either A or C. So I'm going to print minimum is A or minimum is C, depending upon the inner if getting exercised, right? And this else corresponding to the outer if statement, right? Because this if A less than or equal to B, if it is true, then we went inside this true part of if statement. And all this aligning is nothing but the true part of if statement, right? This outer if statement. And then we followed by this else, which is corresponding to the, so you need to think about the pairs of this if and else. So the which if is paired with which else. So you can see like this if is paired with this else, and this if is paired with this else. And here you can see we are using this if along with optional else statement, right? So here we are using else statement in both the if statement, right? You can use it without using the else in any of this if also, right? That's possible. This is perfectly all right. But then again, depending upon what kind of logic that you're going to embed in your program, in your code, you need to be very careful, very clear that this is correctly embedded, correctly written. Any incorrectness in this logic will make your program incorrect. It's a very simple idea, right? So here you will understand now from this week onward that writing this kind of code where you start making decisions, you start deciding, you start checking condition, take decisions, right? Your program will get into like more involved, but then more powerful things that you will be able to do it, right? So that is what, how like the power of the language will be which will be exercised, right? So we can write more powerful program. So this is one of the very useful statement that allow you to make decisions. And we will see that in the next week, we are going to discuss about the loops. This is like another construct. So if or if else, and we'll see very shortly, if statement, right? If else statement also. These are again like a kind of a variation of if construct or this conditional statement. So these different kind of conditional statements allow you to build your logic in a very structured way, where you can also understand that whether you've written correctly or not. You can debug your code, go through this code, figure out that if you have made some mistake and correct them, and again run those programs properly, you can correct those kind of mistakes. So you can write, you can use these kind of more powerful kind of statements in your program. That's one kind of statement, which is like decision statement. And then next week we'll discuss loops. So I can tell you, like using these fundamentally three different kind of statements. One is assignment, which we have already discussed and you're already familiar with. And I hope you're comfortable with using assignment statement, where you assign the right side of an expression, right side of assignment statement to the left side, which is typically represented by a variable, right? So that's the assignment statement, right? Now we have this if statements or variation of this if statement, that if can come independently, I mean, without else, or it can come with else. You can have nesting of if with f within if, right? Very interestingly, if the inner if, there are innermost if within outside if, then it still remain one single if statement. Very soon, like, you will be able to figure out that yes, this is one single statement. Only thing is, like, more complex conditions that you are trying to check, and therefore there are inner if statement getting into an outer if statement. But this one single statement only, which is like one outer if, right? We are making it more complex because the complex logic need to be built in, need to be expressed in the code, right? That has to be checked, right, in your program. So that's why you're writing that kind of code. So the conditional statement and then the loop statements, which is like the topic of the next week. These three statements together, assignment, these conditionals and loops, I can tell you, you can write any kind of program. All programs, I mean, irrespective of the, I mean, most powerful or most difficult kind of biggest kind of program that we can think of, they can be written using these three fundamentally different kind of statement programs. So this is one thing that you should be knowing about, that while you program, in any programming language, these become the fundamental building blocks of a programming language. Assignment statement, conditionals, loops, right? The repetitive statement, which, I mean, the construct will allow some logic to be repeated multiple times, right? We'll see that how we use, how do we do that in a very simple way. Again, things are simple. Only thing is, like, you need to follow very closely what we are discussing and get it clear here only, or in your lab. Very and don't wait for long to get them clear. The week we have decided, the course that we have designed, it is designed such that those constructs, the code construct, the code building blocks that we have discussed, all related things should be clear in that week only, because the following week we are going to build upon our learning of the previous weeks, right? So we are going to use those constructs. So if you are not clear of something in the previous week, then obviously this is going to create problems for the following week, and your experience might be a little difficult to learn programming. But I can tell you, if you are following us, then things are pretty simple, pretty straightforward, and we are, I mean, incrementally building our experience. And after some time, maybe few weeks, you'll find you're much more confident to write your given problem, and you can solve those problems. There's another construct called functions, which we have already started discussing, and those functions which we have used, like print functions, input functions, and then in the last week we shown that how we can write our own function and which we can use in our own program. The function doesn't add the capability of the programming, as I said, right? The three fundamentally important, all important construct that we need to write any complex program is assignment, the conditionals, and the loops, right? What functions allow us? Functions allow us to write modular code so that we can combine some code and give it a name like a function and pass some values, and it does something and useful stuff. And so I can write my code not just one single 1,000 or 10,000 long lines of code, right? Rather than I can put, let's say, 10 functions out there, each containing 20, 30 lines or 10 lines. I mean, depending upon, I mean, the purpose that function is doing, and my main code will then come down to only 10, 15, 20, 30 lines, right? Because the rest of the code is organized. So functions allow us to organize our code in a much more modular way, right? It doesn't add the capability of the language per se, the computation that we do as a part of programming, but it allows you to write more modular code, more understandable code, more manageable code, right? Quickly understand. I mean, code can become quickly complicated as you start adding more and more lines of code. But we can manage that complexity elegantly in a modular fashion by writing those functions. So functions are very useful, obviously, but the fundamental building blocks of a programming language is three statements: assignment, conditionals, and loops. Right. So you can see like this the second part of this else, which is like this if statement. This is like the if statement here. Like one outcome is true, another outcome is false, and the second part is coded in this code. In the same way as we coded the first part, the left part of this branch, this if statement, and this is like right part of this statement, this else part of this writing. This is when this condition is evaluated to be false, right? So things are pretty simple, but only thing is like you need to be a little careful because you will be using them for the first time for many of you. So you need to be careful so that to understand that how we write that the if statement, simple if, or if else, or if statement without with or inside outer if statement. So nesting of if statements, right? So just like this earlier example, the previous slide, we have seen that this is nesting, right? There's another construct which is called elif. So what we are going to do is like if followed by elif and elif, mini elif, sorry, elif, and then finally and last else statement. So let's say if you want to do multiple nesting, right? Multiple if within if is going to be, right? So rather than doing this and making your code looks like a little complex, we have this idea. I can tell you again that this idea is a kind of optional. It allows you to write a code which looks much better than if you don't use this construct, this statement, and still you can write the code. But the problem here is that your code will look really difficult to follow, right? Because it is going to be quite messy. I mean, if statement getting inside if statement, and it can be a little more difficult to understand and when it need to be debugged. See, many times what happens, you write the code and the code doesn't produce the kind of output that we are looking for. That means there is some error somewhere in the program that you've written. So you go and figure out that where is the error so that you can fix that error. You can correct the code and run it again. And you can hope that this time it will run correctly. It will produce the correct output. So going back in the program, checking where you made the mistake, it's called debugging, right? Figuring out the bugs. So wherever there is incorrectness in the code, we use the term called bug or the issues, right, in the code. And those issues or those bugs need to be find out and need to be fixed. And this whole process to finding and fixing this bug is known as debugging. So if you don't write the code in a very friendly fashion, right, it can, not be rewarding. It can be troublesome because to debug that code will be more difficult. So why people suggest to write your code in the most elegant and most simplest way so that one can quickly go through, even if it is your code or if it is somebody else's code, can go through it and can understand the code and can figure out if the code is not performing correctly, then we can figure out why it is not, fix those kind of issues, identify the bug, fix them, and most likely your code will be correct. So debugging is very integral part of this coding, right? So when you write the code, you're going to continuously debug your code to ensure that your code produces correct output. Not going to happen in one go. You have now already seen that you write some code and it doesn't produce some output, right? It doesn't produce correct output. It is producing some error, right? And then you check your code again and correct it, and then again check it, and still you are getting some incorrect. So again you go back. So you see, this is kind of quite an iterative idea of programming, that you write the code, doesn't produce the output, go again and see the code and figure out what is wrong with the code. You fix that, you correct that, and again check your code, run your code, and so on and so forth. So So this is like quite an iterative process, and it's very important for you to write the code in a way that you can read. I mean, just do this experiment. You write some code, and maybe for 2 weeks, don't see that code and come back to that code. You will take some good time to understand that what you did in that time. Most likely you're going to forget that logic. And for a small program, small 2-3 liners, that should be fine. That may be obvious, but if it's slightly bigger code, you'll find that you forget what you did actually, and you will take some time to again recall that exactly what you did and why this kind of output is getting produced, right? So it is important. Again, I cannot emphasize more than this, that it is very important to write the code in a format which is make it simple to read, simple to understand every time you go through it. Not for you, for anybody else who's likely to use your code, right? So this elif construct, right? This is a special kind of nesting where if we have like nesting of if statement, like chain of if within if and also. So what we can do is we can make use of this elif statement rather than this chaining, which, so for example, I can actually do this if condition 1, then do S1, else if the condition is 2, then S2, else if condition is 3, then I can do S3, else. So I'm checking one condition at a time. If this condition, then do, if there's another condition, there's another one. And then this else will make all these else are actually causing this else to be this code block to be shifted this direction, right? So if you put more if statements, your code will move this side, right? And you can see, right, it will be slightly more involved to understand, right? A simple idea here is what I can do is like I can use this elif construct, which is nothing but else if. So in short, you can say like it is a short form of else if. So we are using this like else if, which I can say that elif, and I can put it in the aligning the same if statement. So this if, else if, else another if, else another if, and finally this else, which is like the if none of this if is satisfied, then there is a default action to be taken. Maybe it is empty, nothing is to be done. Only it's like when the condition is satisfied, then something is to be done. If there is no condition satisfied, nothing is to be done. Then you can have this else block empty, or you can put the default action that if none of these conditions are satisfied, I mean, is evaluated to be true, then there's like final default action to be taken. In case that nothing, in any of this is satisfied, that means that part, this if statement is finished, because all this if is nothing but orthogonal with each other, right? And that we are checking in the sequence. So which one is any of these condition is satisfied? That means that particular true part of the code will be executed, and that finishes the if part. I mean that the if statement is finished because some part of if is like evaluated to be true, and that makes this whole if statement to get serve the purpose. Evaluated that condition, satisfies that condition, execute that corresponding code, right? So this code got executed, and then after this it will come out and the following code will start getting executed. So I hope you understand between the difference between this if, else if, and this nesting of this if statement within those if the outer if statement, rather than we can actually use a if with elif, which stands for else if. Else if. So these are like one condition. If it is satisfied, this is done, and the execution control will come out from this if statement. This is again treated as one single if statement. So you know that either one part of this if is got executed, it will break this rest of the part, because one is already checked, the condition is checked in the sequence. This is something that you need to be careful here, that the checking of the condition in a particular sequence. So first this condition is checked. and then the second condition check, and whichever is found to be true, the true part of this condition will get exercised, that code will get exercised, and then the remaining part of this if statement, like the remaining elif statements are not going to exercise any further, because one of them is got in that sequence exercise. So it is assuming that you have placed this checking in the particular proper sequence. If it is not properly sequenced, then again there can be issues, there can be bugs, right? So while you can actually use this more powerful statement where we can check this condition in this sequence, you need to be careful that which condition is to be checked first, and then the second, then the third. So those sequencing of checking of this condition is important here. Otherwise, you may be making a mistake here. And finally, this else block, what it suggests that, yeah, right? We have this else block where the remaining part of the, I mean, if none of this condition were satisfied, then maybe you want to do something, and there you can write the code in this else part, right? So to summarize this if statements, we can use if statement, we can use if else statement, and we can use this if elif, right? And multiple elif actually, and finally else. So you can use simple if without else. You can use if with else. You can actually perform nesting if also, if within if, which we have seen the example, or you can use this statement, which is a little more structured one, make things looks more elegant. The if, elif, and else statement, right? So there are like multiple ways to solve a problem. I mean, you may be writing only if statements, and you can actually do it. I mean, this is just like how do you build your logic in program. So you may be making use of only simple if statement, or if else statement, or if statement within if statement you can write, or you may be using this this elegant if elif multiple times, and then followed by the final default options, which is coded in the else part of, right? This if statement. So you might be using any of that, and maybe it may be possible at times like that you can actually do it in either way, right? But then which one to be used, right? So we can have multiple ways to solve problems, but which one we are going to use? So you must give some brain to it to figure out that which one is more readable, more maintainable, right? And also like more efficient. So maybe like writing in one form may reduce the computation required. So it will save some CPU cycle, some fraction of time. It can execute faster, right? So it's a faster way of executing. Obviously, this will be too complex to discuss at this point of time, but I can always emphasize here that which is very useful for us at this moment when we are beginner in programming, that we should be able to write the code which is more maintainable, right? More readable. Readable and maintainable means you can read it, you can understand it, you can make changes, and making changes like you are addressing this problem of maintainability, that the code can be maintained. That means we can make changes in the code easily, and while we make changes, we make these changes correctly. That means this code is more maintainable, highly maintainable. If the changes need to be done, which are done with slightly difficulties, then we say that it is less maintainable code. So it is important to understand that writing code, it's just not a trivial idea. It's a very useful idea that how do you write your code, right? And what kind of statements or the construct that you write. Okay, so let's say it's time for asking you a question. And you can use your chat box to answer this quiz. So we are having this Boolean expression here. I can put it one more bracket to make it like more readable. So we have this one simple condition, 5 less than 2, and this Boolean operator. And the like 3 divided by 0 greater than 1. Anything divided by 0, you know that it is infinity, right? And in computer, we don't have any infinity data. but it will generate like large number. So it will definitely give us an error because this operation is not defined, right? So obviously it's an array operation. So what is the outcome of this when this expression is evaluated? Can you suggest that what is going to be the output? False.
Sir,
False, sir.
false, sir.
False.
Don't you think that this contains
False.
that the,
False.
False. False, sir.
Sir, error will be displayed.
Sir, error. Error.
yeah, many of you are writing error, and many more than those who have written error, they are suggesting that it is false. Now here this is
False, sir. False.
false. So it's like runtime error, or I don't know, I don't care. I mean, let's say these are the option false. This one of the options is false, and many of you are suggesting false, and nobody is any of you suggested true. It's like 5 less than 2, and you know that this expression, this simple expression, will return me false because 5 is not less than 2, right? So if I say 5 less than 2, this is not true, so it will return false. Not true is false, right? So this will return me false. And then we have this AND operator. It's a Boolean operator which takes like false is one side and this AND is, and then if it is like true or if it is false, then we know that the outcome of this answer, this expression, false and true or false, I know that it is always false. Because once one of the ingredient of this AND operation, right, the one of the operand, right, if it is false, then we know that the whole result is going to be false. So what is happening here? That once it is evaluated, in normal case, what happened that we can expect that this part is evaluated, which is false. Then this part will be evaluated, which is like 3 divided by 0. This will result into error, and your program should crash. Should report an error because 3 divided by 0 is an error. This, though we haven't discussed about this kind of error, but I can tell you at this point of time that when you do 3 divided by 0, you can do it on your VS Code. Just write 3 divided by 0 and enter. You'll see that it will generate an error, which is like divide by 0 error, right? So what we can expect that if this part is evaluated, then it should give me an error. So overall, I should get an error. But the answer is we are going to get this false. Now, why we are going to get it false? That's what this short circuit evaluation, right? So we discussed short circuit. I mean this term, right? Short circuit evaluation of Boolean expression. So what it does, see, this is AND operator. So it needs 2 operands. So obviously it will start evaluating from left side. So it will start evaluating this. It will evaluate this and it will get it false. As soon as it gets false and this is AND operation, we know that we don't need to evaluate this. Why? Because one of the operand, if it is false, then the result is going to be false, irrespective of what is the value of the second or third or those kind of values. So even if like there are multiple AND are used with multiple operands, sorry, right? So all these like, so if this is evaluated, because the evaluation start from the left hand side, so if this is evaluated as false, then it short circuit, I mean it stop the further evaluation and output the result as false. So since it will stop, it will not evaluate this. When it will not evaluate this, so that will not execute it. This part will not execute, then no error will be raised, and therefore what is going to be raised is the outcome of this expression is as false, and therefore the answer is false. No error will be raised. Then if in case like if it is if we don't have this short circuit evaluation, then we can expect that this part will be evaluated, this part will be evaluated. Evaluated means executed, And if this part is executed, then definitely it will raise an error. It will complain. This part, the execution of this part will complain, raise an error, and your program will terminate with suggesting that there is an error. But since the compiler, while evaluating this, apply this short circuiting, right, of these operators, right? So as soon as this 5 less than 2 is evaluated to be false, then you can simply check this by changing these operations, and you can figure out that this is true. If it is true, then it will evaluate the second part also, and you will find an error. That's a very interesting thing, right? And you need to do these kind of exercises of your own. See, I've seen like a few of you has suggested that something which was asked in the examination was not discussed in the class. I cannot discuss all those things, right? Programming, it's not this simple and a small idea. Whatever construct that we are discussing, they can be used in a very, very different way, maybe infinitely many different ways, right? Because it's a program, just like we write or we speak out, right? We use this natural language, so we can tell a lot of things, right? So how many statements I can there or are there in English language or Hindi language? Can you list down all those statements of English? Like maybe a billion or 3 billion? Obviously, it's not. They are infinite. You can create every time like new statement, right? And therefore the people who teach you English will not tell you that this is a very big set of all those sentences which can be formed using using some natural language. And similarly in programming language also, the kind of statements that we can use or the combination of these operations or operators, they can be like come up with like many different ways, virtually very large number of ways, if not infinite. So you know that I cannot cover all that. I mean, some of them I can cover and I can provide a general idea, which you need to experiment yourself to get yourself more confident, more familiarized with these operators or these operands, and see that what if I write this expression in this form. Just do it. You don't have to wait for anybody to tell that what will happen if you use this in this particular way or that way. So this is very important, and please put enough effort so that you find yourself much more confidence, much more better place. Since you have done it, you will get that kind of feeling that you know that how this expression work or this operator should be used correctly or incorrectly. What kind of use will result into incorrectness or errors, and what kind of use will allow you to write it correct. So this is what you need to do it, right? Short circuit evaluation I already suggested, and this is another example which will suggest to you that how this short circuit evaluation would work. This is a little more complex expression. This is a Boolean expression. This is like not. Then it has this. This is one Boolean expression. So another simple Boolean expression. This is another, right? So you can see here we have like 2 greater than 5 is false. When this is false, you know that this is AND operation, which is ending these two operands. One is this, another is this, right? And since it is evaluated to false, this will not evaluate. So you can see like this is not going to be evaluated. And then since this is false, the whole result is going to be false of this side. And then there is an OR here, right? But then before this, we have this not. So not is not outside of this whole expression, but actually not is attached to within this. So the result of this is false, and then false is flipped with this not as true. So we'll get true. So so this true part, and then followed by this OR, and there's another expression, right? Now you see this is OR. So one of them is true, you know that the result is going to be true. So if this is true, so this is evaluated, and therefore this evaluation given result is false, applied with this not and with given true. So this part was not evaluated, and this part will also not evaluate because this result, left hand side result is true. and then we have or, and then whatever is the right hand side, we have, once we have this true on one side, then then we know that the result is going to be true, irrespective of whatever is the right hand side. So this part, the right hand part, is not evaluate, and we are going to get the expression evaluate to be true. So that's what, I mean, you need to experiment again. Like there can be again millions of ways, like these kind of expressions can be written, and but then very fundamental things will remain as it is, right? What is end operator, how it works, which kind of operands, and what kind of results it produces, right? So if any of the operand of end operator is false, then the whole result is going to false. Whereas for the or operator, if any of the operand is true, then the result is going to be true, irrespective of the. That is very simple ideas which will remain valid irrespective of whatever is the actual expression or complicated it is, and you can actually solve those things. So while you evaluate an expression manually and see that if those kind of results work out same way when you execute that kind of code, you need to be aware of this precedence. Right, so precedence we have already discussed that when we use multiple operands and with different operators, which operand or which operator is which will be executed first, and then the second. So which part of the expression will be evaluated first, and then will be combined with the rest of the part in what sequence. So that is what you need to know, so that you can figure out that how this whole expression is going to be evaluated. So this order of this operator evaluation matters a lot, right? Because if this order if it changes, then it may change the end result. That may be possible, right? Similarly, the associativity, right? So this associativity is applied to the operator of the same class, whereas precedence applied for the operators of different classes, right? So which one is going to be evaluated? And the order, right? The precedence and associativity identify the operands for each operator. So which operator will be evaluated first, and that operator which operand, right? It takes which operand, so that will be figured out by this precedence and the associativity. And it is very simple idea, just like in mathematics that you are familiar with, that this precedences, which we have already discussed, like you know that the multiplication is more precedence, more will be evaluated first, then the plus or minus. So plus minus is like in the same, whereas multiplication, there are plus the multiplication or division sign with plus minus, the multiplication will be evaluated first, then the plus operator will be evaluated. So you know that this is applicable for any kind of operators that we use in our expression. And to make things more explicit and more clear in case of any confusion, you put them into brackets so that you explicitly suggest that compiler to evaluate this as a whole, right? Putting by these brackets. So by putting those brackets, we disambiguate any, so we remove any confusion if we have, and it will be done correctly. So very important, if you use parentheses to make it more explicit. There's another quiz which I am going to tell you, and I'm asking you. You can again use chat box to put your answer. Let's say you have this statement y is like 0.1 multiplied by 3, and in the next statement you are using this if statement, where we are using this condition y is not equal to 0.3. So what we expect here, when 0.1 multiplied by multiplied by 3, it is going to give me 0.3. So this is a normal expectation. So y is 0.3 here, and now I'm checking here that if y is not equal to 0.3, so we know that this is going to be, this should be false, because y actually equal to 0.3, because 0.3 equal to 0.3. This will give me 0.3. So 0.3 not equal to 0.3. Absurd. I mean, this is false. I mean, this is true, because 0.3 equal to 0.3, right? So this operator will return true when this condition doesn't hold, right? But if this is if y equal to 0.3, then it will return me false. So then if it is false, so I should be getting let's have peace. Now, yeah, so what do you think that what if I'm going to get this launch a missile?
Let's have peace.
Let's have peace. So
Let's have
peace. So many of us are like believing that since 0.3
Second one.
Launched a missile.
Launch a missile. Okay, so one of them you suggested like launch a missile,
error.
and maybe a couple of more will say that launch.
Launch a missile.
So you see, very interesting that this class is a big class, like 300 people. So half of you may very well say that launch a missile, and half of you can say let's a peace. Now, obviously, either half is going to be correct because this is one of the two options is going to hold. Either we are going to have like this print as launch a missile, or we are going to have this print statement because this is with else. So we know that for sure either this part is going to get executed or this part going to get executed, right? We are now familiar with this else statement. Perfectly all right. Interestingly, we are going to have this output as launch a missile. And this is ridiculous because y equal to 0.1 into 3, which is 0.3, which we expect that this y should give me 0.3. And then if I compare 0.3 equal to 0.3, so this with this not equal to operator, so that will return true only when these two are not equal, right? But then since these two are equal, it will return false, right? And therefore it should give me like this false part, which is else part of when this condition evaluated to be false. So we know that else part will get executed. So I should get let's have peace. But instead I got the launch a missile. So there is something wrong with this floating point operation. So if you can recall, in the beginning, I suggested that be careful with operations when we perform in comparison when we use these floating point numbers or floating point variables. A simple idea I would suggest you write this code and use a print statement to print what is the value of y here. And that will suggest that whether y is 0.3 or y is something different than 0.3. And very interestingly, no, it's not a string, right? This is a number, this is a floating point number only 0.1. So 0.1 will make this 3 as floating point. So y is a float variable here. And we are comparing this y with the float variable. So there is nothing, no problem regarding the type comparison. So there is no error per se, right? So this code doesn't have any error per se. Only thing is, to our amazement, right? It has outputted launch a missile rather than what we expected this code to produce as let's have peace. Everybody wants peace. But why launch a missile, right? 0.3 equal to 0.3. But interestingly, as I said, if you want to get an answer here, just try to print this y, right? So you compute this y and insert a print statement here, where you print y. And what you're going to get is like 0.3
0 0 0 0
0 some number of 0, and finally the 4.
Excuse me, sir.
Haji.
Sir, if we round y to one place, sir, then we can get let's have peace.
Very good. So great. I mean, so but then see, as a beginner, we didn't know, right? You will agree with me that we expected in a very common sense way that 0.1 multiplied by 3 is 0.3. But we can check at the same time, I mean that if this we get this kind of output, launch a missile, that means this was not the case. This has given me a wrong output. My condition, if I check, my condition is I have written it correctly. I don't see any errors here, but I got an output which is incorrect. I mean, what I expected is like this to be printed but I got this printed. That is, there is something definitely wrong here with this expression. This expression, I expected it to be evaluated as false, but it was evaluated to be true. That means what it found is like y is not equal to 0.3, which we think that it should be 0.3, and that's the problem. So the problem can be, see, in the programming, when you write the code, I mean, you can quickly check also. I mean, just you need to put your some brain and figure out that if there are some errors, some misbehavior of your program, you can quickly figure out that why it is misbehaving. And here also, since this expression has provided me a wrong output, so what is wrong? I mean, it's simple. You're comparing y as 0.3, y should be as 0.3, and it is saying no, it is not 0.3. So if it is not 0.3, then what it is? And therefore you can always check this print. So when you print y, you will get that y equal to this number, which is 0.3, and then many zeros, 10, 12 zeros, and then followed by a 4. And this number 0.300000, and then followed by this 4. Just think about it. I mean, is it equal to 0.3? And now you will say that no, it is not 0.3. That irrespective of like, though it's, if we round it off, then it is 0.3. I mean, now round since I truncate this, have this lower down this precision, then it will be 0.3. But if we use this number as it is, this is not 0.3, because this is 4 at some place after so many zeros. So though the difference is very, very small, but still there is a difference. And that's why this difference has caused this result to this expression to evaluate it as true. And then when it was true, that means these two were considered as different, and that's why then it will output as nonsense sign. So very interesting idea here, which you should be familiar, which should be careful when you deal with this floating point number. I mean, if you deal with integers and others data type, no issue, no worries. But when you deal with floating point number, you need to be careful, because there is a fundamental difference between this floating point variables or floating point values with the other integer or other string values, right? And what is that difference? That this floating point numbers are to be represented in the computer. So how one represent, right? See, somehow we need to store these numbers, floating point values also. Now, how do we store those values? With what precisions? When these numbers are like this, 0.3, then we say that, okay, 0.2999999 up to what 9 places, they can be considered as 0.3. Because if you say that 0.29, I would or to double or up to 4 places, I can always say that there is a number 0.299999, which is actually lying between 0.3 to 0.2999. So you see, because it's a real number exists, right? And there are infinite many numbers possible between any two numbers. In fact, even like between 0.3 and 0.29, there are infinite many numbers, right? And you cannot use all those numbers to be represented in computer memory, because computer memory is finite, right? So there is one thing that we do to represent these numbers. I mean, this type of data in computer memory is we approximate, right? And we assign some kind of memory to store that. Again, this memory is finite. So that means we can have a approximate representation of a given real number. We never going to have very exact representation. We cannot, because that's impossible task, right? And that's the issue when we deal with this kind of arithmetic which involves floating point number. So I'll provide a solution to this. This is some more detailing about like why this floating point number representation in computer memory is a difficult idea, right? and I can tell you, like, this is altogether a very different subject, even like a different altogether a topic to deal with floating point numbers in computer memory. How do we represent this floating point number? Why this makes this is very useful? It depends on that what kind of numbers, floating point range that you are dealing with. You might be targeting the weights of atoms or weights of electrons or neutrons. You know, right? 10 to the power some 20 or 20, 30 numbers. Those precision we will be required to be used in our program. And maybe we, in some other extreme case, we might be dealing with the weights of planets, right, or large planets, right? And that's a very big numbers, right, positive numbers. So you know that we might be like in our application might be dealing with these numbers, it's like very, very large number or very, 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 very infinitely small numbers, depending upon where we are. And therefore, it will be very difficult idea that to represent these numbers to a level of precision, right? Because we have a finite memory, finite way of representing these real numbers. So it's very important to keep to understand and to be careful while we perform some arithmetic with floating point numbers. But I will give you a very simple idea to deal with this situation. And let me stop here and let me share the
Sir,
yeah.
sir, I have a small doubt.
So I think just one thing, before you speak, we have already overshoot the time of this class. So I'll take that demo code in the first hour or the part of initial part of this lab turn at 2 p.m. where we'll take the demo code and where you can experiment with this demo code yourself and get familiarized with this Boolean expression, Boolean variable, Boolean operands, short circuit evaluation, and then these if statements, if else, simple if, or if else, if elif kind of statements in programs. So there is an example included for those scenarios. You can play around, you can make changes, things that comes to your mind, you make those changes and run it, and maybe you can clarify your doubts by yourself. But if you have further doubts, we will definitely be taking those doubts. Yeah, so you can, those who have classes, definitely they can leave, but then we can have a few question answer till the point that we have covered so far. And in the afternoon session, we will be taking the demo code in a half an hour time, right? Yes, so I can take a few questions if you have.
Thank you, sir.
Yeah, so do you
Sir,
have some questions? I mean, if you don't have any class, we can take
sir,
some.
I have a doubt. Sir,
Just one by one, right? So maybe like you raise your hands and we can go through in that sequence. So that sequence will be visible to all of us, and that will be a kind of contention resolution protocol that we will be following in the question answering. Okay, so go ahead with Ronit.
Sir, just now you have run that code, no, sir, 0.1 into 3.
Right.
Sir, I've run the same code in mine. It is showing false as the answer, sir. I've done in the same way, but it's showing false, and I've used that if else also. It's showing false. It's coming out 0.5 only. Like I've done 0.1 into 5.
0.1 into 5. Okay.
Yes, sir. It's coming out 0.5 only.
So that's what I mean. What you suggested is one more interesting example of that. This results can be unpredictable. I mean, sometimes you get your intuition correctly captured, and sometimes you don't. I mean, you do it with 0.3, you don't get it right. That answer. But if you do it with 0.5, you get it. So again, this is asking for more careful understanding that the results can be sometimes like unpredictable. I mean, it may go either side. So again, and it's not that like it will be always more than or it will be less than or it will be equal to. It depends on when, see, just like here in this case, I ask you to print the value of y and it is printing 0.000 some zero followed by 4. Still it is truncating and it is giving you some zeros and finally that 4, and that 4 final is making it different from 0.3, right? If you are doing it with 0.5 and maybe like 0.5, it has more number of zeros and therefore when it truncates, it gets same as 0.5. So it is giving you the same result. I mean the result that you are getting here the let's have peace, which is expected one. So this even calls for further carefulness because in very similar cases, in one case it is giving you one result and in very similar case giving you another result, right? Please keep your mic muted. That's the problem, right? So those who are the person who is asking question, he can definitely keep on muted, but then the rest I request them to keep muted. So I have some more example to discuss it with and more clarification that why it is happening, that how these numbers are represented and how we can know about that, what exactly these numbers are represented. In Python also, right? Python, I mean, because it's a language specific issues that how a particular number store that is real number is stored in a language, right? How the memory is allocated, how compiler reserve that memory to store that particular number. So right, so every language will have its own way of like representing. So they need to do some kind of approximation. For most of the practical purposes, it may be fine. But some extreme cases like just like the example I've taken, like when we are taking an application where we are dealing with the mass of an electron, which is like very small, finitesimally small, or mass of a planet, which is very large number. So, so things will matter there. So we'll definitely going to figure out a way to deal with this data. I mean, this is not a problem here which cannot be dealt with. We can deal with this problem in a very simple and elegant way. And I'm going to give you a solution which will work for all cases, irrespective of whatever the scale of numbers we are dealing with. So don't worry about this. But this will be interesting. This will be very important you to know this kind of arithmetic may give you wrong answers wherever you may think that there's nothing wrong in your code. So that's why we have added this as a separate topic to discuss that what this floating point arithmetic may result into something which we don't expect, right?
Sir.
Yes.
Sir, one more thing, sir. Sir, when we are using elif statement, if suppose the first part itself we get true as the answer, so it will not verify the next statements, right? Like if suppose we verify first if statement and it comes out true, then it will not verify the next other elif statements, right?
Absolutely.
Only if it comes as false, then it will come down to the next
Second one. Yeah, so maybe what you are providing is like, if I miss that point, I mean, this checking will be done in that sequence. So first is hit, I would say that, okay, that satisfied, that results into true first condition, first part, wherever like, so the remaining part, it will skip because that part, the corresponding true part will get executed. And this is how we say that, okay, this if statement has completed. It does, or it did its purpose, sir. So we need to know about like how we can use these statements, right? And therefore our logic should be correctly coded. And therefore the sequence of checking, and I think I have already suggested that in which sequence you put this elif or this expression one after another, that matters a lot. Because if you change this, obviously it will result into a different outcome.
Yes, thank you.
Sir,
Yes, Ronit.
when second week and third week response available?
Oh, I am going to announce this. Maybe this weekend for 4 quizzes, which will be completed by this weekend. We are going to release their answers, and you can check your attempt on this Sunday. Of this, can you unmute and please?
Yes, sir. I have a question regarding using arithmetic operations, sir. In the previous quizzes, some question were there and I was unable to solve them.
So, I think if you are this like a specific question and where you want to discuss about this specific example, you can share slide with your TA and get an answer if you get it. Or you
Sir,
can-
is there any sequence to use these arithmetic operators? Like in mathematics, there are BODMAS rule.
No. There is no such sequence. I mean, you can. I mean, see. Here we are the designer of the solution. So we write our programs. The program is to be designed first. So if you can recall in the very first lecture, I started with, discussing that when we solve problem using writing programs, we have to design this solution. It's not that you will start writing something and it will come. No. We need to mentally create the model of the problem and the solution steps so that you can write the correct program. And while you write those programs, those statements one after another in that program, you have to make sure that each statement is written correctly. I mean, it is doing what it is supposed to do while we solve problem. So basically, each statement is a kind of like part of the design of your solution, right? So if you have done mistake somewhere in any statement, that means your program is incorrect there at that statement. So that incorrectness will definitely be figured out. I mean, when you run programs, your output will be different. Maybe for some input it may be correct, but some other input it may not be correct. So still it will be considered as incorrect. A program cannot be considered as correct if it produces correct outputs on 1 input or 2 input. We have to actually ensure that the program is correct on all possible inputs that we can get. But checking this on all possible input will be a difficult idea. That's why we do testing. That means we figure out that what different inputs we can give so that to test all those scenarios, different scenarios, orthogonal scenarios. And if the program produces correct output in all those inputs, then we can have more confidence, much more confidence that this program is correct. I can tell you, and this probably you should know, that there is no way to suggest that this program is correct by establishing some mathematical way, right? So since we are familiar with mathematics, many of you probably, so you know that you have established some theorems, some proof of correctness you have already done, but that doesn't apply to programs. And I mean, people have in the research they have done for small programs, very small program, 10 line, 15 line, but we don't write 10 to 50 lines. What we do is like we write million lines of code, and there is no technique which will suggest even like 100 lines of code. It will be very hard to prove the correctness of the program. So what we end up at like checking that whether the program is correct or not, your solution is correct or not, which is written in the form of program. We design test cases, run those test cases, multiple inputs basically, and see that if any of those inputs, if the program misbehave and doesn't produce the kind of output it should produce. So if any of these inputs it doesn't produce the output, that means the program is incorrect. So for all those inputs, it should be producing correct output. Then only we will assume that your program is pseudo correct. I mean, this is a notion of pseudo correctness of program. We cannot say any time that my program is 100% correct. What we say that your program is pseudo correct if it satisfies all those test cases which were designed by some designer of test cases, right? Which has those people knows about how to test the program. So if testing a program itself is a big domain, and we are not going to cover that in this course, so don't worry. But then I can tell you like testing is nothing but identifying what inputs we should give and what output the program should produce. So those input output combination, for each input, there will be one test case. So designing 10, 15, 100, 200, depending upon the kind of program we are testing it. So there are designing policies or strategies, test design in strategy, which allow you to become a tester also. But for now is we are going to be developer writing code and trying to show that our code is correct. So maybe we can run on some test cases where we can think of those test cases ourselves, those input output pairs, and we can check our program by giving those inputs and can check that whether the program has produced correct output for all those inputs. So this we will do informally, not very formally, just like the software testing is done or program testing is done, but we will be doing it informally. We will be randomly or from our some consciousness, from some tricks, we will decide that what input I should be giving and what output it should be produced. So this is how we establish correctness. So having said that, this is very subtle for a program to decide that, I mean, we need to decide that if this program is correct. In principle, we should be writing program where all the statements should be written correctly. So if you have taken this care to an extent while you have written those statements one by one, and that sequence is correct, that logic, this conditional expression, this if statement, if they are written correctly, they are, evaluating or exercising correct logic, most likely your program is correct, you are saying. But then we cannot believe on some program which is written, irrespective of howsoever care somebody has taken in writing program, you need to show that it works. So that we can show only by running it and giving some inputs, right? Right. So we will be doing it, not very formally, but some informally, and very soon you will be familiar with this idea also.
सर जो y equals 0.1 into 3 वाला एग्जांपल था, तो उसमें हम लोग को अगर करेक्ट करना है उसको, तो नेक्स्ट लाइन में राउंड y1 लिख देंगे, यही ना?
देखो मैं आपको इसका नहीं, ये आंसर जो है वो एक तरीका हो सकता है, लेकिन दिस मे नॉट वर्क. आई एम गोइंग टू टेल यू द मोस्ट general solution of this problem, and that is that you will accept as a very standard way of solving this kind of problem. So what you are suggesting is like a way to fix it, but then it may not work on all the other cases. And you have seen that one of you has figured out that if I use this 0.5, 0.1 multiplied by 5, then this code and we like make this correction that this is like so what among you suggested, like
Sir,
do it with this 0.5, then it will, this code will run correctly. It will not give this output, but it will give this output, which is what we are expecting. So you can see that in the very similar situation, very similar. I mean, how can 3 will not work and 5 should work, and then there can be many other numbers also, right? Infinite many numbers. So you are not going to check it for each and every numbers, right? So how to deal with this kind of situation where we have this arithmetic operation to perform, and then we should be like confident of our logic to be correct. So I'm going to tell you a fix of this problem for places where these arithmetic operations are taking place and the results are being like compared, like two numbers which are like computed in your program, and then you compare these two numbers. So how you're going to compare these two numbers, which might be obtained from different computation, and you want to show that whether two numbers are equal or not equal. So I'm going to tell you those kind of fix. Yeah.
So can we get a copy of the previous quizzes and our responses so that can help us?
You're not going to get a copy. You can because these are like with very hard work we create those kind of things, and we cannot circulate this so that it can be shared everywhere. Then we have to every time like create all this. You know that this is part of hard work which goes into creating those kind of quizzes.
Okay, sir.
Okay. So we are going to provide you the feedback, definitely. So we are going to provide you that whether you correct whether you attempted correctly or not, or what was the correct answer. So you will be able to see that. And I'm going to
Okay,
give
sir.
you a slot, time slot, which will be a small amount, like maybe 1 hour or so. It will be announced in advance that in this hour it will be available. You can go through your quizzes, all the attempted quizzes, and can see your responses, correct answers also. But maybe 2 hours of slot, and then you can figure out that what mistake you made and all those. But then it will not be for all time. It will be for
Okay, sir. That will be enough, sir.
yes, that's what the purpose should be served. So that's what the professional stuff we are engaged in. That we should be helping you to the extent it should be, but not for. I mean, you know that we have all sorts
Yes,
of.
sir.
Yes,
Sir,
सर इसका करेक्ट आंसर तब क्या होगा?
किसका?
यही y equals 0.1 into 3 वाले एग्जांपल.
3 वाले का तो करेक्ट आंसर लॉन्च से मिसाइल दिखा हुआ है या मैंने शेयर किया?
नहीं सर, अगर हम लोग को ये करना है, लेट्स हैव अ पीस.
हाँ, लेट्स हैव पीस करना है तो अभी इसका करेक्ट आंसर मैं आपको कोड में बताना चाहता हूँ. बेसिकली हम क्या करेंगे कि एक थ्रेशोल्ड लेंगे. एक थ्रेशोल्ड मतलब कि जो कि बहुत डिपेंडिंग अपॉन कि किस रेंज में हम डील कर रहे हैं. तो जैसे हमारे अगर रेंज है लाइक 0.1 या 0.01 से like 100, 200, 1000. I mean, we need to figure out that in which range of data we are dealing with. So we can decide a threshold, let's say 0.000501, right? Or 60701. And then what we are going to do, we are going to compare these two numbers, take the difference of these two numbers, take the absolute value of this difference, and compare it with the epsilon. If it is less than that epsilon, right, that means we are saying that these two numbers are equal. So that difference is very small. That means very close. These numbers are equal. So, but then this epsilon value will depend on the application, that which kind of number, which range of number we are dealing with. So what we can consider as equal and what we cannot consider as equal, depending upon, let's say if we are dealing with an application where we are computing the weights of electrons. So like 10 to the power minus 30 or minus 29 or 28, right? Or weight of atoms, right? So you know that the precision required is like very small, right? So there this epsilon is going to be very small. So that this particular comparison, that whether the two numbers at that small scale, very small, infinitely small scale, still makes sense when we compare two very small numbers to be equal or not. So the idea will work for all situations. Only thing is we need to be mindful to figure out that what should be this epsilon. So this idea I'm going to discuss in the afternoon lab. Don't worry.
sir,
Yes, please.
sir, can you tell us once again the memory thing related to the floating data type?
So come in the afternoon lab and we'll discuss it. It's the first thing in the afternoon.
Okay, sir. Thank you, sir.
Okay, so I stop here. We'll discuss this demo code and which will be shared with you also, so that you can also play around and can feel all that, can have the complete idea, very good idea of that the concept that we have discussed, and then you will be solving those assignment problems afterwards. Okay, so I stop.
Thank you, sir.